This last section is essentially the same idea that I talked through in statistics about linear regression. Um, we hit a little bit of this actually in the last section where we're talking about a mathematical model. So let me just give you the story of that again, and I'll kind of tell you the whole picture. So in a mathematical model, what I want to do, all it means is I think the real world can be explained by a math equation. And the simplest of those is a line. That there is some relationship between two variables, and they seem, as one goes up, the other one seems to go up. This keeps happening with the same slope. And so they seem to be forming a line, a linear relationship between the two of them. And so what we're going to do is we're going to look at different variations of this, and I mentioned this in the last section, where we saw the pattern of the dots when we plot these, and we begin to think that it takes on some other relationship. It may not just be linear, it could be exponential, it could be logistic. Now, at the end of that last section, we were stuck trying to find an equation ourselves using the points that were given to us. But there's a much better way, which is just we will use technology to map out the best, in the case of linear, the best line that would go through those dots as the best they can. In the real world, the relationship isn't going to be perfect. And so what we do with regression here is we take the dots, and the technology is going to make the best straight line right to the middle of the dots, the best curved line, exponential line, the best logistic line, whatever it is. So the process for all of this is exactly the same. Now, it's well explained here in the documentation from the book, but I would attach my linear regression video, and it's all just going to be variations of the same thing. So I'm going to keep this brief, and I would supplement this with the linear regression video because it's going to tell you the whole story. So I'm referring to linear regression. Here we're going to talk about exponential regression. And so we have all the details here. Let me show you some data. So I have this data. And what I'm going to do is, it's written kind of a weird way, but everything here is going to be like my x's. Everything here is going to be my y's. And I'm going to put this in list 1 on my calculator and this in list 2. I need to match them up. 0 goes with 1, 0.01 with 1.03. Match them all up. And then, once I've got them in there, I would graph it using stat plot, and then you go into Zoom 9. So if you go into Zoom, you hit 9, that's, I think it is called stat plot. So now you'll have a clear picture of the dots, and you could take a look and see which pattern that you think it follows. Is it linear? Is it exponential? Is it logarithmic? Is it logistic? And then all you do, so again, I'm referring to my linear regression video, you go into stat and then calc, and there we've been doing linear regression. Well, you can do exponential regression, you can do logistic regression, anything. The process is all the same for each of them. So here we're going to crunch this, and we're going to see, okay, I look at the dots, and this definitely looks to be an exponential growth. So I'm going to have the computer, the calculator for me, calculate what kind of exponential growth this is. I'm not going to use individual points and try to solve for A or B. I'm going to let it do the best it can at creating a line that goes through these dots. Now these are perfect, it looks like, but it's not always the case. So I use exponential regression, and I get this equation right here. So that's it. I'm already done. Here's our exponential model that says, hey, we think the real world explains this relationship exponentially, and there it is. Now in my videos, I like to talk about, if you saw the linear regression video, you're going to watch it. I'll talk about, I would want these x's and y's in terms of the actual story, but in college algebra, I would let these go. Like I can just call them x and y, that's good enough. So in terms of the story, this would be BAC and relative risk of crashing, but we'll just roll with it. Now, why have you done it? We have done this in order that we could predict. We want to take guesses at values that we didn't have. I didn't have any data values associated with a BAC of 0.16, an x that equals 0.16. Well, if this relationship has been established, and I feel confident this is telling some truth about this situation, I could then make predictions about what would happen with a BAC for a number that I didn't have. So I put in 0.16 and I crunch it, and I think I'm expecting, I don't even know what the story was about, but I'm expecting a relative risk of crashing to be 26.35. Okay, what did I want to say? Oh yeah, one last thing. R squared, I don't know how much I talk about it in the stats videos too, but R squared, essentially, there's a little more to it here, but the way I think of it, the easiest explanation is R squared tells you how good of a job your mathematical model is doing at explaining the situation. 1 would be perfect. It's absolutely perfect. All the dots all line up perfectly. It's clearly exponential. It's a perfect model. So we want this value to be very close to 1. Now 0.97 is not perfect, but that's a very good model here, saying that this fits the pattern of exponential very, very well. And we're thinking it does a good job of explaining the story. Okay, now I'm not going to work this again. It's exactly the same as my linear regression. I would put these in my list 1. I'm going to put these in list 2. And again, the instructions are here. My video will also show you on the calculator up on the screen. So how to put the just stat edit. Then you can take a look at it with stat plot. Where am I? I'm getting lost. Okay, here we are. So I'm assuming, yeah, they're telling us it's exponential again. So if I graph this, I'm going to see, okay, it looks something that's exponential. So we're going to use that exponential regression command from the menu here. Exponential regression out of stat and calc. Just hit that and enter it, and it's going to create our values for us. Now, what's the point of that? We could then check it. I don't know. Okay, so what are they saying here? 1 year after graduating would be 12 months. So all of these are the months after graduating. We could then use this information to try to predict what value of debt they would have if X was 12. Okay, now this is exactly the same idea with logarithmic regression, exactly the same. I'm going to look at the dots. I'm going to say, hey, this appears to follow a logarithmic pattern. And so I'm going to enter it into list 1 and list 2. I'm going to crunch this using linreg here. So just a different command, but the process is the same. I'll get the A and B off my calculator, which will provide me everything I need. So again, if this isn't clear, like you're not sure where to find it, I'm entering these in an example of linear regression. So here's my X's, here's my Y's, that's list 1, that's list 2. So okay, so it's a little confusing here that they're talking in decades. So I think what they're asking you to do is to enter this as 1, this is the second decade, this is the third, this is the fourth. So just be careful. That's what it would be saying to do with how we enter our X's. But otherwise, it's the same idea. So we plot it and we see something like this. Well, it's not perfect, but this appears to be something like a logarithm. So we use our linreg, and if this wasn't clear earlier, it's going to give you output that tells you the A and the B. Well, this was A and this was B. You know those numbers, you just plug them in to your model and you've got it. Okay, now why do we do that? Because we want to predict what would happen if X were 14. So I'm plugging in, so that's outside of the data that I had, but I could use it to predict, put 14 in, crunch it, and we get a life expectancy of 79.1. Okay, these all work the same. Just be careful how they're asking it. Here, they're again asking this. I don't know if it's years after. Yeah, that's a little bit of a strange way to do it. I would have started with X being 0, but they're telling us they want us to call this year 1, year 2, year 3, year 4. So that's list 1, that's list 2. You do the same thing again. You're going to crunch that, get your mathematical model, and then you could plug in, which is again weird, 16 for the year 2015, 16 to crunch and see what we would predict to happen in the sales in the year 2015. All right, we have one more video that's going to be logistic here, but it's going to be the same idea. So again, if you had any real questions, this wasn't making sense, watch my linear regression video where you'll have all the calculator commands up on the screen. It's the same process.